Hello viewers. So in today's class we are going to take up some important problems on limits and continuity. So here we'll solve some problems in which the function is given as continuous at some particular point, and we have to calculate uh, the value of some constant. For example, here we have the constant k, right? So the topic is on finding the value or values of a constant given when the function is given continuous at an indicated point. So here we have to find the value of k. K is the constant given if the function given below is continuous at x equal to minus 1. So here this point is the indicated point, right? And fx is given as continuous, right? So here we are given that fx is continuous at x equal to minus 1, right? So now here we have to find the value of k, and we'll make use of the definition of a continuous function. So what is a continuous function? A function is said to be continuous if the limit at some point x tends to a is equal to the value of the function at that indicated point, right? So the function is said to be continuous if the limit, that is the right hand limit and the left hand limit, both exist, right? Left hand limit and right hand limit both exist and they are equal. So we can say that the limit x tends to a f of x exists, and this should be equal to the value of the function at this point, right? So here a is minus 1, right? So this is a. Now let us find this limit, right? So the limit x tends to minus 1, f of x is given by limit x tends to minus 1, and we have this function x square minus 2x minus 3 over x plus 1. Now here we'll factorize the numerator, and this can be factorized by using the method of splitting middle term. So we'll have x square minus 3x plus x minus 3, and we can write it as x minus 3 x plus 1, right? So this limit is limit x tends to minus 1, and here we have x minus 3 x plus 1 divided by x plus 1. So x plus 1 and x plus 1 get cancelled, so we are left with limit x tends to minus 1 x minus 3, and this is equal to minus 1 minus 3. Here we'll substitute x equal to minus 1, so we have minus 4. Now f of a is f of minus 1, and we are given f of minus 1 at x equal to minus 1. The function is given to be equal to k. So now the limit is equal to f of a, and this limit is equal to minus 4, and f of a is k. So the value of k is minus 4. So this is how we solve this problem. Let us take some more problems. Now here we have the problem: find the value of k if the function given below is continuous at x equal to 0. So here the function is given as f of x is equal to sine square kx over x square when x is not equal to 0, and f of x is equal to 4 when x is equal to 0. So we know that a function is said to be continuous if the limit x tends to a, f of x is equal to f of a. Now to find this limit, what we will do, we'll have limit x tends to 0, because here a is 0, this is a, right? So limit x tends to 0, f of x is equal to limit x tends to 0, and for f of x we have sine square kx divided by x square, right? So now we have to solve this limit, so we'll write limit x tends to 0, and we have sine square kx over, now if we write here k square x square and then we multiply it by k square, it means we have multiplied the denominator by k square and the numerator by k square, so that these two terms get cancelled, and we again get this expression. Now we have multiplied the numerator and denominator by k square, because we know that limit x tends to 0, sine x over x is equal to 1. So now this term can be written as limit x tends to 0, sine kx over kx whole square, and here we have k square. Now this limit is equal to 1 due to this result, so we have 1 square times k square equal to k square, right? Now f of 0, because at x equal to 0, f of 0 is given as 4, and the function is given as continuous, so limit x tends to 0, f of x is equal to f of 0. So this limit is equal to k square, so we have k square is equal to 4, so k is equal to square root of 4, and this is equal to plus minus 2, right? So therefore the value of k is plus minus 2, right? Now let us take this problem. Here we have to find the value of k if the function kx square when x is greater than or equal to 1, and fx is equal to 4 when x is less than 1 is continuous at x equal to 1. So here we have to find the value of k. So what we will do, we'll again make use of the definition of a continuous function. A function is said to be continuous if the limit at x tends to a is equal to f of a, right? So here a is 1, because we have to test the continuity. Actually it is given as continuous, so at x equal to 1 the limit must exist and equal to the value of the function at x equal to 1. So it means limit x tends to 1, f of x should be equal to f of 1. Now here the function is given as or defined in two ways, that is when x is greater than or equal to 1 and when x is less than 1. So what we will do here, we'll find out the left hand limit and right hand limit, right? So let us find the left hand limit. So the left hand limit is given by limit x tends to 1 minus f of x, and we'll substitute x equal to 1 minus h where h is greater than 0. So when x tends to 1, h tends to 0, so limit x tends to 1 minus f of x is equal to limit h tends to 0, f of 1 minus h, right? So now we have limit h tends to 0 and f of 1 minus h, because here we are finding out the left hand limit when x is actually less than 1. Here we have x is 1, and here we have all values less than 1. Here we have all values greater than 1, right? So now f of 1 minus h will be determined from this function when fx is equal to 4. So we have here f of 1 minus h is equal to 4. So the limit is equal to 4. Now for right hand limit, what we will do, we'll have limit x tends to 1 plus f of x, and we'll put x equal to 1 plus h, and when x tends to 1, h tends to 0, right? So the right hand limit becomes limit h tends to 0, and we have here f of 1 plus h. So it means when we have to find the left hand limit at x equal to 1, we'll put x equal to 1 minus h, and when we have to find the right hand limit, we'll put x equal to 1 plus h. So now this is limit h tends to 0, and f of 1 plus h will be determined from this function, because here x is greater than and equal to 1. So we have k times 1 plus h whole square, right? Now limit h tends to 0, k times 1 plus h square is given by limit h tends to 0, k 1 plus h square plus 2h, and if we substitute h equal to 0 here, this term and this term becomes 0, so we are left with only k, right? Okay, now f of 1 is equal to because from here we'll find the value of f of 1, because x is equal to 1 when fx is given as kx square when x is equal to 1. So here we'll have k times 1 square, that is k. So now applying the definition of continuity of a function is said to be continuous if the left hand limit equal to right hand limit equal to f of a. So here left hand limit is here 4, right hand limit is k, and f of a is f of 1, right? So 4 is equal to k, f of 1 is equal to k, so finally the value of k is equal to 4. So this is how we solve this problem, right? Now let us take one more problem. So here we have to find the value of k if the function given below is continuous at x equal to 2, right? So here the value of a is 2, and we'll again make use of the definition of the continuous function. A function is said to be continuous if left hand limit exists, right hand limit exists, both are equal, and these two are equal to f of 2, right? So left hand limit is given by limit x tends to 2 minus f of x. So again what we will do, we'll put x equal to 2 minus h, and this will become limit h tends to 0 f of 2 minus h, right? And h is greater than 0, and when x tends to 2, h tends to 0, right? Okay, so now for the left hand limit we have to take the values of x less than 2, so we'll make use of this form of the function. So we have limit h tends to 0, 2 times of 2 minus h plus 1. Now if we put h equal to 0, here we'll have 2 times 2 minus 0 plus 1, so this is 4 plus 1, 5, right? Similarly for right hand limit we have limit x tends to 2 plus f of x, and we'll substitute x is equal to 2 plus h, where h is greater than 0, and when x tends to 2, h tends to 0, right? So we have limit h tends to 0 f of 2 plus h, and we have limit h tends to 0 f of 2 plus h. So here we'll have to take the values of x which are greater than 2, so we'll make use of this form of the function. So here we have 3 times x, x is 2 plus h, and minus 1. So now h equal to 0. Here we'll substitute h is equal to 0, so we have 3 times 2 plus 0 minus 1, so this is 6 minus 1, that is 5, right? So we see that the left hand limit and right hand limit both exist and are equal, so it means the limit x tends to 2 f of x exists, right? Now f of 2 is equal to k. We are given as k, f of 2 is equal to k. So now limit x tends to 2, f of x should be equal to f of 2 in order to be a continuous function at x equal to 2. So this limit is equal to 5. So we have 5 is equal to f of 2, f of 2 is equal to k. So the required value of k is 5.